Day 145, Honors Physics, Kirchoff's homework problem number 41. I thought of one more thing, that a preliminary step that would be good to think about. Here we have multiple loops in this particular problem. Before you even start labeling the branch currents, it's a good idea to label your junctions. In this problem, there are 3 junctions. Doesn't really matter how you label them, but it's good to label them. This point right here where 3 wires come together, I call that point A. Here's a junction, point B. And there can be, actually there's 4 junctions here. Here's point C. There could be 4 or 5 or 6 wires that come together at a junction, but these so far have only had 3 wires at each junction. Here's point D. Those are the 4 junctions. I'm going to label the other corners of this box as well. I'm going to call this E, and then F at the top here, top left. Top right is, I'm going to say G, and lower right is H. That's an H there in the lower right. So I have the corners of the diagram labeled, but the junctions for sure, A, B, C, and D are the 4 junctions in this diagram. All right, then I have currents already assigned. I have 1 amp right here. That's from B to D. And as I'm going along here, I'm just going to write this in, because I know that's 1 amp and 2 ohms. That's already 2 volts. So that's easy pickings. And from B to C. From B to C, that current is 1 amp, and therefore I know that that's 8 volts. So I know that branch current. I also know the current from AF, G, C. So from A to F to G to C, that's 2 amps as labeled. I don't know the resistance up there on the top. I'm looking for that. But I do know that that current is 2 amps. Therefore, if I look at this point right here, point C, I can already see that I have 3 amps going in. There's only 1 more spot to come out. So I know from point C down to H over to D, that current right there is 3 amps. These are kind of like Sudoku puzzles. One thing leads to the next thing. So it's good to label these as I go along. But I'm focusing on labeling all these branch currents from one junction to another junction. So I have that 3 amps now. Now I'm looking down here at point D, and I see that I have 4 amps going in. So I have to have 4 amps coming out. There's only one place to go out, and that's from D to E to A. So therefore, I know the current from here to here to here is 4 amps in that branch. 4 amps going in, 4 amps coming out. Now I'm looking at point A, and I have 4 amps coming in, and I know this up here is 2 amps going out. 4 amps going in, 2 amps going out that way. 1 more spot. Therefore, right across here, there must be 2 amps. Because the first law says the current going into a junction must equal the current coming out of a junction. And now I know V equals IR for this 3 ohm resistor here between the points A and B is 6 volts, because V equals IR. All right, so I've got a lot of things already figured out. So this one will fall into place fairly quickly. I'm looking for, let's see, the battery voltage here. Once again, this E stands for voltage. Voltage here, and this resistor. So let's look here. One of the easier ones, I think, to pick right now, and you'll get used to this, is this loop right here, because that loop, all the current arrows in those branches are all clockwise, so everything's conventional. Bottom line is I'm going to have negative 6 volts, minus 2 volts, plus V3 right here, and it's almost overkill to do this, because I will let you put a bunch of numbers on a diagram. I would like you to do in this case that, you know already that E1 is going to be 8 volts, but here's how it would officially line up. You would be looking at loop, I just highlighted it, loop A, B, D, E, A. In that loop, you have 3 elements, and generically it's V sub 1 plus V sub 2 plus V sub 3 equals 0. And I'm doing everything conventionally if I'm going with the arrow flows of current. So the first thing from A to B is the 6 volt potential difference for the 3 ohm resistor, but it's going to be negative 6. So I'd have negative 6. And then I come down from B to D, it's going to be minus 2, plus V sub 3 equals 0. Well, the V sub 3 is that E sub 1 in the diagram. So V sub 3 has to be 8 volts. In other words, that's E sub 1, if I'm going to use the notation they use. E sub 1 is 8 volts. So that's Job number 1 done. Okay, now, well, let's do something a little unconventional this time. Let's look at this little loop over here. Once again, it doesn't really matter where you start. I'm starting at B to C to H to D to B. So this one will be a little bit trickier with signs. So it's good practice. So loop B, C, H, D, B. I'm going to go in that order. There are 3 elements. V sub 1 plus V sub 2 plus V sub 3. I'm just using that as a generic statement. V sub 1 refers to my 8 volt or my 8 ohm resistor right here if I'm going from B to C, and I'm going with that blue arrow, my assigned, and that was actually given. That was given. So we know it's that direction. And I'm going with that arrow, so therefore it's going to be the conventional -8. So V sub 1 is -8. Write that down up here, upper right, -8. And then I'm going from C to H with the battery. The battery is pointing down, a long part of the battery, the positive point of the battery is pointing down, so I'm going with the battery, so that'll be a plus V sub 2. You can call it E sub 2 if you want. And then I'm going to go from D to B, but now I'm going up from D to B against the current arrow. So I'm going from D to B up, and I'm going against this blue arrow. All right, that's the key that makes that resistor +2 instead of -2, because I'm going against this blue arrow right here as I walk from D to B. So that is unconventional. That will be +2 equals 0 for that battery, or that resistor. So therefore, if you do the math here, you get V sub 2 equals 6 volts, not 10. Okay. Now, we have the upper resistor. And I'm going to do it the hard way just to kind of show you what can be done. There's other ways of doing this. You could do the full outer loop would be the easy way to do this one. But just for practice sake, I'm going to do a more difficult loop, because any loop will give you the same answer. I'm going to do the loop from A to F to G to C to B to A. I'm going to do this loop. All right? You could do all the way around the outside. It'll give you the same answer. I'm going to do from A to F to C to B to A. So I'm doing, just to show you, loop. If you want to practice going around the outside, you can. A, F, G, because any loop will give you the right answer. A, F, G, C, B, A. And when I go around that loop, I'll have 3 elements again. V sub 2 plus V sub 3. That's just a generic statement. I'm not referring to any particular resistor in particular. Although if I'm starting at A, V sub 1 matches up with the first R at the top there. And I don't know that right now. I know V sub 1, I don't know it. So I come around from, if I'm going around now, I went through this one. I already did V sub 1. This is going to be my V sub 2, but I'm going back against that assigned arrow. So instead of the normal -8 volts, it's going to be +8 volts. Very important you put +8 there. +8. And the same thing is going to be true of my 6 volts for this from B to A. That's going to be normally a -6, but I'm going against that arrow that's pointing towards me as I walk to the left. It's pointing to the right. So that's going to be +6 equals 0. So V1, and I could have, what I could have done in the computation, it doesn't really matter. I could put a negative in front of the V1 in the statement that I wrote down, or it comes out as V sub 1 equals -14 volts. Well, it's got to be -14 in the loop rule. But bottom line is you don't need to put the negative in the final answer. Up by the resistor, it was negative in the to make this come out to be 0. It's 14 volts. And when you do the loop rule going with the current, that would be a -14 that you'd plug in there. So that's 14 volts. Well, once you know the voltage, you can use V equals IR to get R. I'll just use black. V equals IR for that upper resistor. The V is 14, I is 2, R is unknown, but now it is known. R is 7 ohms. And you could have seen that if you went all the way around the outside, the 2 batteries are 8 and 6 would also give you 14 volts for that upper resistor. Technically a -14 volts computationally to make it come out to be a potential difference of 0 if you go around the entire loop. But there's our answers there. Good luck with these.